the idea is is pretty clear here. Just how absolutely abysmal this is for performance.
What's up guys, CJ here. Now, in my last video on this topic, I mentioned that, so unless anything new comes out that I think I can bring my unique perspective to, I'm gonna put pirate software behind me and just keep moving forward. One of Thor's criticisms of that video, when he wasn't busy trying to smear me as a grifter,
it's just another, like, YouTube grifter trying to fight for relevance, dude. That's all that shit is.
Despite the fact that my channel has been consistent for the past 5 years, is that I wasn't specific enough.
You can review languages, many concepts are transferable. Concepts can be transferable, but specifics are not, and that's the problem.
Today's video sponsor is me. I built this platform called getcracked.io, which focuses on covering everything that is not lead code related to the technical interview for languages like Python, Rust, C++. That involves concepts like language knowledge, networking, operating systems, concurrency, computer architecture, etc. As you can see, we have over 600 problems that will really test and sharpen your skill set. Check it out. And so I figured maybe I can look for new information that I can bring my unique perspective to. Other creators, including myself, have covered the code snippets that he has shared publicly on stream. And so I thought to myself, wouldn't it be nice if I can address Thor's critique by finding code that he's written off stream to really get into the details? So I decided to scour Pirate's website on the Wayback Machine and noticed that he actually included his source code resources as early as 2018. Just to be clear, these are the resources for his demo version of Heartbound. I was able to extract the code that he's written using data.win and the Undertale mod tool, and I'd like to focus on that for today's code review. Now, I know that a lot of people might be thinking, why are you doing a review on old code? Well, I decided to compare that 2018 version of the code that Thor himself distributed with the code available in the demo version of Heartbound, and at least at the places that I found major issues, there wasn't any difference. Now, I also want to stress that this video is going to be made in line with my own values as a developer. That being that we are reviewing mistakes so that others can learn from them. And in doing so, I will be providing alternative solutions. That doesn't mean that my solutions are the best improvement that can be made or a silver bullet that can apply in every scenario. But it will give you an idea for a general direction that you might want to take your own project in case you encounter similar issues throughout your development. Now, I'm going to be categorizing issues in this review based off their priority or severity, rather. So we're going to be starting with large or major issues, then going to medium or intermediate issues, and then ending off with small or minor issues. So let's get into it. I want to start by observing his lighting engine by taking a look at the file drawLight. Let's take a look at this drawLight method and hone in on the first case statement. Let's break down at a high level what's going on here. Thor loops over every pixel in a sprite, checking if each pixel touches or overlaps with a certain object. If it does, it then applies a light effect repeatedly, and with each repeat, it makes that light fade more diffuse. He then draws said colored pixels at that location to simulate the light falloff. Now, let's say your sprite is 128 by 128 pixels. That's 16,384 position checks he's doing per frame per light source. If he has multiple light sources or is trying to run at 60 FPS, you will feel the lag. Now, he actually checks collisions twice for each pixel, and he doesn't have any early exit should his second instance of that check not execute. If light diffuse is 5, it's possible that he does an additional 4 iterations that returns false every single time. In the case that we have the exact same 128 by 128 pixel sprite, that is not just 16,384 checks. That's 98,304 checks at worst. What's worse is if you observe the second case, where light comes from the right instead of the left, you'll notice that Thor copied and pasted the entire left code into the right code's case, only changing the signage of light distance. What he could have done here is handled both right and left in the same case and simply applied the signage to light distance based off the direction of the light, and also apply the direction in which we iterate in the for loop differently based off that same signage. How do we improve upon the code here? Well, we really don't. We throw it out in favor of layers, surfaces, and shaders. I decided to bring on a game dev who has years of experience in GameMaker, working not only on his own hobby projects, but also as a contractor for a studio in order to explain this fundamental concept.
I'll just draw a little diagram. This is basically how his code works is he has a sprite that basically looks something like this. This is sort of like a beam shape, kind of what you'd expect from like a beam of light. For every pixel in the sprite, so each one of these is a pixel. It's basically going in the draw event and doing a collision check at like each pixel. And it's basically checking and checking and checking, and if the pixel is on the sprite, it'll draw it. This is the starting point over here, and the farther away the pixel is from the starting point, it like blends it differently, and that'll create some kind of gradients. But yeah, this is a terrible way of doing it. I drew, what, like 5 pixels here? This is like super scaled up. A sprite like this would be like hundreds and hundreds of pixels. And to check each of them on the X and the Y like coordinate, like every single frame for every single like object doing this is going to be like abysmal for performance. The way that I had suggested would be better is you have the sprite, same one, and also any other sprites you want to do this with. So keep in mind, if you're using this system, every single other object that's like a light beam or whatever is going to have to run this code like independently of each other. With this method, all the objects at once, say you just have some random other objects over here that you also wanted to be light sources or something, I guess. All of them at once can draw themselves onto a surface. A surface is basically a picture almost, just made of pixels. You can make them any size you want, but in this case, all we'd have to do is make the surface the size of the camera. This would basically just be starting point, wherever the camera is in the room, right here. And these are all the objects that the camera would be seeing. We would just create a white surface, basically, just a surface that is just completely opaque. And these objects will draw themselves onto this surface. And before they do that, they'll set their GPU blend mode to subtract. So what that does basically is if I were to draw like this square here onto this white surface while the GPU mode is in subtract, it'll basically just erase right here. Like it'll take a chunk out of this white surface basically. And this area here will be like transparent on the surface. Like the pixels will have an alpha of 0, meaning you'll just be able to see through them basically. So all these objects just need to draw themselves onto this white surface. And this basically makes it like, it's kind of like they're like little cutouts basically. And then what you do is you have a separate surface, and this is very common. A lot of lighting systems will use a surface like what I'm about to describe, where it's just completely like transparent, and then any light sources or gradients or light beams, whatever, draw themselves onto this surface. Most lighting systems you'll see, unless they're using shaders, they'll usually use a surface like this where they will draw any lights. Think of this as like a gradient. Draw any lights they want just onto this surface basically. Usually they'll use some fancy stuff with blend modes and all that to make it look good. Literally doesn't matter here. And then what you do is you take this surface, you set the blend mode to subtract again, and you draw it on top of this surface. So you set the target surface to this one, and then you draw this surface on top of it, basically. And that will result in this surface. I guess I'll draw the result surface here. It'll basically result in only the transparent parts of this surface will remain like on this surface. So see right here we have this little beam shape. So you'd only be able to see like the parts of this little circle gradient basically through this cutout shape, if that makes any sense.
Yeah, that makes sense. And you'll still have your light diffuse or light fall off there as well.
Yeah, and you can make this, I mean, another limitation of this only goes, from what I can tell, directly like right or directly left. It does not seem to be able to rotate or go up and down. Now I suppose you could do some weird stuff to get it to rotate, like maybe draw it onto a separate surface and rotate it, but it's still very suboptimal. With this, let's say I wanted to rotate this beam. This beam right here is going directly to the right. I could literally just draw it like this, like in a different direction. And the gradient would remain the same. It would be a lot easier. You wouldn't have to do any weird, trickery to get it to do that. What I'm saying is this sort of method supports like any shapes and any orientation, and it's much, much better for performance, like drastically.
To really reinforce why this is classified as a major issue in Pirate Software's code, Level 5 Fish decided to profile it against his own surface-based implementation. The comparison code is available on GitHub, linked in the description, and the full 7-minute explanation by Level 5 Fish is available for my patrons and junior dev level channel members. Here's the 2-minute summary.
So I've taken the lighting code and I've imported it into GameMaker. Now, the only things I've changed are this line right here, where it says it's just a conditional basically, and I've just replaced it with true, meaning it's always going to run. And the reason for doing that is because whenever this was here, it would just flicker. So I just took it out. The other thing is I've added this variable here. This will allow us to track how many times a pixel is drawn. So every time this line is run, it will add to this value here. If I press T, it'll display that value, and we can see how many times it's running and how many times it's doing a collision check. I have this sprite here. This is a 800 by 100 sprite, so somewhat large, but not absurdly large, and is not something that's like unrealistic to see in actual projects by any means. I've added it here to this room. It's using this lighting script to draw sort of a gradient of light over it. So we're going to see what happens when I run the project. We have kind of a gradient rectangle basically, but I don't know if you notice something. We are getting less than 20 FPS. That code is running the collision check and the drawing the pixels 80,000 times. I've also gone and created the system that I had previously described that involves using surfaces. So here it is the same sprite, the same rectangle, except it's using this other lighting system. This one right here that I've created. So let's see what happens when I run this project. As you can see, it looks basically the same, except oh wow, our FPS is actually there. I'm actually going to run this in debug mode, and debug mode will allow us to run a profiler, which actually will tell us basically what percentage of performance each one of these objects are using. This was the lighting code created by Pirate Software. It is using 99.675% of performance, roughly. This is the implementation that I came up with, and I'll note it's really nothing complex. It's not super difficult, I think, for most people to make something similar. 0.238% performance. The idea is pretty clear here. Just how absolutely abysmal this is for performance.
I now want to move on to an issue that I would classify as having medium severity, and that is the way that Pirate structures dialogue in this game. Now, the way that he does so is via a two-dimensional array called dialog array, similar to the one-dimensional array that he had for his event timeline. For every single language and every scene, he checks in a GML file that contains this 2D dialog array. This adds a lot of bloat to your code, makes it less navigatable, and also it limits scalability. So as you can see here, each language and each scene has its own file. He also has another 2D array called voiceList. Now, the first index of voiceList is character, and the second is the emotion that that character feels. As you can see, if character 1 has emotion 2, well then this is the sound file that he refers to. If character 1 has emotion 19, well then I guess this magic number just needs to do. Now, how did I know that the first index is the character and the second is the emotion? Well, I wouldn't know just by looking at this. I would have to search for voiceList, and it just so happens that this is the only part of his code where I'm able to tell that the first index is character index and the second index is the selected emotion for that character. What I would do, instead of checking in these files, would be to ship them with my game's local files and assets. I would then partition the dialog assets by localization. Notice how in my chapter1.json file, we have scenes, and scenes has multiple keys, each the name of a particular scene. We start off with Book Dream Intro, which was the name of one of his files that contained a bunch of dialogue. We then go through every dialogue within the list of Book Dream Intro. Each of those nodes contains a speaker, a dialogue ID, a text, emotion, volume, replies, and optionally a next scene if we need to move forward. Speaker will pull up the sprite for Ralph. Dialogue ID can be used to reference said dialogue node later. Text is what we display on screen. Emotion relates to the voice that's being used. We also have an optional list of replies. By optional, I mean it can either be empty or it can contain several nodes. Each one of those nodes contains a text and a next scene. So once a user selects one of those nodes, for example, selects the no you didn't, the next scene moves on to the denial response. As you can see, the denial response scene also has its own separate speaker, text, dialog ID, volume, replies, and pushes you to the next scene. There's really 101 ways to build up on what I just suggested. None of what I mentioned includes obfuscation or saving of dialogue options, but it's better than what exists currently. In fact, it's probably the bare minimum you'd expect from somebody with 8 years of experience in GameMaker. Now let's move on to the minor category. There are several things I'd like to bring up, and I'll try to do so as quickly as possible. My first criticism is useless code. Thor's code is littered with it. Take a look at this case, for example. It contains a switch statement that switches on an object index, but doesn't actually do anything with that index. Instead, it defaults to the damage polarity, either 1 or -1. I've never seen anybody write code like this. Interns that I've mentored, junior developers, it's just really odd and doesn't do anything. A static code analyzer will most likely pick up on this. Many IDEs either come with them built in or support third-party static code tools, so if you're not already using one, consider doing so. You'd also think that a game as art-rich as this would have some sort of color palette instead of just hard-coding colors. The next is unexplained constants. They are everywhere. I brought this up in my original video, and a lot of people said that the magic numbers I referred to weren't really magic numbers because you can use IntelliSense to tell what the actual parameter names are associated with those numbers. Putting aside the fact that nobody should need to hover over a method for 2 seconds to tell what the actual parameters stand for, let alone do this for over 20 methods, magic numbers in their purest form are everywhere in Thor's code. There's at least half a dozen in each file, maybe even more. Take a look at the 100 million here for active color, or the 765 that aren't really explained. In many places where Thor performs I/O operations, he never first checks whether or not that file exists, or whether or not he has permissions to read from or write to that file. Therefore, he never actually handles any exceptions or errors that may result from said operations. Now, I want to make this very clear. If this is your first time coding, good on you. The purpose of this channel is not to discourage, it's to encourage. But what we're seeing here is a repeated pattern of behavior of somebody that claims to have over 8 years worth of experience, at least in GameMaker, and 20 years of experience in the game industry as a developer. But contrary to how much experience they should have, how much they brag about their accomplishments, there's a massive incongruity between what they can produce and who they say they are. If you guys enjoyed this video, please consider liking and subscribing. It goes a long way. If you guys would like to go above and beyond, consider becoming a member or patron. You guys get access to a bunch of really cool and exclusive perks. I want to shout out GeekyBit, Level 5 Fish, and KevinKorDevs for helping to make this video a reality. For those of you that want to check out their links, those of them that want to feature their links will have their links featured on screen. Thanks for watching, guys. Cheers.